Well everyone, today's the day that we're finally allowed to show you all of the benchmarks for Arrow Lake, and we have gone really deep into testing both the Ultra 9 285K and the Ultra 5 245K to see if Intel's claims are actually accurate. And I want to address the elephant in the room about those claims right away, because Intel has said that they are not aiming for massive generational uplifts over Raptor Lake. This for them is like a great sort of reset for all of Intel's desktop CPUs. They are talking now about lower power consumption, lower heat, and generally higher efficiency. Now, one of the biggest changes for Arrow Lake is that it loses hyperthreading. So these CPUs have substantially less processing threads than compared to the 14th gen and Zen 5 competitors. They also run at lower maximum clock speeds than Raptor Lake. So basically, Intel is counting on architectural improvements to overcome frequency and processing thread deficiencies. Meanwhile, pricing for the new Ultra 9, 7, and 5 CPUs neatly threads the needle between every single one of the currently available AMD CPUs. For example, the Ultra 9 285K sits right between the 9900X and 9950X. The Ultra 7 squeezes into the space between the 9900X and 9700X, and so on. There's only one massive wild card though, and that is the 9800 X3D, which is set to be available on November the 7th. But you know what's available right now? That's these cases from Phanteks.
I don't know how Phanteks does it, but the XT lineup offers incredible value for your money with these mid-towers. The interior is ready for today's challenging needs with a 360 up top, up to 10 120mm fans, any GPU would fit, it's BTF ready, and your choice of a cool presentation with the XT View model or high performance with the XT Pro and Pro Ultra. All of the illumination is tasteful and appreciated at this price point, and everything is double boxed with protective corners so the XTs travel safe. Check them out below and spend responsibly.
Anyways, if you want a little bit more about the nuts and bolts behind Arrow Lake, a little bit more about its specifications, Intel's claims, and a lot of other things, we did a full video about that. It's linked right up here. This video, on the other hand, is all about the benchmarks and testing Intel's claims. The entire intent of Arrow Lake is to move beyond the preconceptions from the 13th gen and 14th gen CPUs that Intel processors run hot, they require a lot of power, and they are just, I guess, failure prone. Now, Arrow Lake is all about efficiency, and more efficiency, but is it actually more efficient? To find out, we have the Ultra 9 285K and Ultra 5 245K that'll be put up against their spiritual predecessors, the 14900K and 14600K, along with a comprehensive lineup of other CPUs. And the ground rules here are pretty simple. We put every single one of them through 3 different all-core workloads to see what the average and peak power consumption was overall. Here are the rest of our system specs and setup in case you were interested. There's a few other things I need to mention, like we're using the public release of Windows 24H2 along with the latest AGIZA for AMD's Ryzen 9000 series, and Intel's 14th gen processors have the latest vmin shift mitigating 0x12b firmware applied. Settings like PBO were turned off on AMD, and we're using Intel's default performance power mode on Arrow Lake and 14th gen systems. And it looks like we can confirm at least some of Intel's claims, because the 285K chugs back less than the 14900K, while the 245K needs way less power than the 14600K. Meanwhile, both are still far more power hungry than the competing Zen 5 CPUs. Also, as Intel has tried to limit issues with the 14900Ks, we've seen the peak power consumption of our chip get gradually reduced over time. Those changes though, they didn't impact constant power draw or either of the other 14th gen CPUs. So overall, the 285K needed about 23 watts less than the 14900K. And yet I'd actually argue the 14600K versus 245K story is even more interesting, since the reduction here is massive, to the tune of almost 40 watts. And that leads to CPUs that are a whole lot easier to cool than the previous generation, especially the Ultra 5 245K. But there's 2 things to point out here. Neither Arrow Lake processor runs at lower temperatures than their direct AMD competitors, and while the 285K might technically run cooler than the 14900K, needing a 360mm AIO to hit 75 degrees isn't something I'd really brag about. Alright, so overall we can now validate 2 of Intel's claims. Number 1, the Arrow Lake processors consume quite a bit less power in multi-core workloads, and they also yes, are a lot easier to cool. But there's a lot more nuance to the efficiency conversation than just pointing out lower power numbers, because efficiency in this case is offering the same amount or more computing horsepower while consuming less power. So did they do that? Well, in Cinebench R23 at least, the answer to that is yes, absolutely. The Ultra 9 285K offers a lot more performance than the 14900K, while the 245K offers 14600K numbers while needing much less power. And yet we also have to remember the 9950X needed almost 30 watts less in full core workloads, but it matches the 285K's performance here. Meanwhile, the Ultra 5 245K chugs back a lot more power than the 9600X and 9700X, but its scores are on a whole different level too. And the situation, well, it pretty much repeats itself in the latest version of Cinebench, though the 285K and 245K are able to add a bit more distance between themselves and everything else. While it's amazing to see the 285K narrowly beating a CPU that has a dozen more processing threads, we still have to remember that Zen 5 can offer some incredible performance per watt, a lot better in many cases than Arrow Lake. As for single core results, well, I'll admit it, I was really hoping to see the jump forward Lunar Lake offered on the laptop side, and yet these are more of, I guess you call it like an incremental uptick rather than a generational leap. Still, by a narrow margin at least, they're the best results we've ever seen from Intel CPUs. The real test for Arrow Lake is multi-core CPU loads in real-world scenarios, since it has a processing thread deficiency in almost every situation. Nonetheless, the 285K actually beats the 14900K by a decent amount in Blender, while splitting the difference between a 9950X and 9900X. Personally though, I think the Ultra 5 245K is the more impressive CPU here. It might only have 14 threads, but it beats the 20 thread 14600K while staying comfortably ahead of the more expensive 9700X. Raw CPU focused video transcoding and Handbrake also sees a pretty big win for the 285K, where it runs ahead of the 14900K and even manages to beat the 9950X. Meanwhile, the 245K still does really well too, especially when you consider it needs about 40 watts less than the 14600K while also running 10 degrees cooler. Meanwhile, Houdini sees things tighten up quite a bit for both of the new Intel processors against their direct competitors. And I think overall these tests highlight something that'll continue through all heavy multi-threaded workloads. The 285K will generally win against the 14900K and trade blows with the 9950X, and the 245K will stay ahead of the 9700X. The only negative point here is both lose against Zen 5 on the performance per watt front. From a creator workload perspective, in most situations, video editing renders will be largely bottlenecked by the GPU anyways, especially in a program like Resolve, which doesn't use Intel's QuickSync engine as a co-processor for the type of files we're using. Adobe's Premiere Pro does, however, use QuickSync while rendering out via its media encoder, and here the updates Intel has made to Arrow Lake do make a difference. They pushed the 285K and 245K to become the fastest CPUs we've ever tested here. So I guess that answers one of our questions. Is Arrow Lake more efficient than Raptor Lake in all-core workloads? The answer to that is yes. Absolutely. It can provide better performance while consuming less power, and it's a lot easier to cool too. But one of Intel's biggest claims about this whole new architecture is what happens during gaming, because according to them, we should be seeing even more significant cuts in power and heat while playing our favorite titles. But to test that, we actually went a lot deeper than we normally would. First of all, I need to talk about how we're presenting the data in every single one of the gaming-related tests, because it's a huge departure from what we've done before. On the left side of the graphs, you'll see results done at 720p and low detail settings. The intent here is to minimize GPU bottlenecks as much as possible, which should technically allow the processors to really stretch their legs. And while I know this is completely unrealistic for someone with a modern gaming PC, it also provides a glimpse into CPU longevity as more powerful graphics cards are launched in the future. Basically, if a processor is far ahead at 720p with a 4090, it will likely be able to live through several generations worth of GPU upgrades at higher resolutions without causing a bottleneck. Meanwhile, if you want to understand what these processors can offer right now in a real-world scenario with more realistic settings, we're also including results done at 1080p with the highest detail settings in each game. Finally, in order order to remove any confusion, because I know these charts are really packed full of information, the order of the CPUs won't change. You have the new Arrow Lake CPUs at the top, followed by 14th gen products, then the 7800X 3D, and finally the Ryzen 9000 series right here. So the first thing we did was measure processor power across all of the 15 games we tested, with each run lasting 10 minutes, and then averaged everything out. And it looks like Intel's claims were pretty accurate here too, because even with the 0x12B firmware reducing its power consumption, the 14900K still needs almost 60 watts more on average than the Ultra 9 285K. It also sips back less than the 9950X and 9900X. The same thing goes for the 245K. It doesn't even hit 70 watts overall, which pushes it below the 9600X. The only processor here that needs less juice is that ultra efficient 7800X 3D. Power consumption between 720p and 1080p is pretty much the same overall, but there are some slight reductions at the high resolution since less pressure is put on the CPUs. I also wanted to highlight the worst case scenario we found with Cyberpunk. This game pushes CPUs like nothing else we've encountered, and here the Ultra 9 and 5 extend their power savings over 14th gen, but they lose a bit of ground against Zen 5. As for temperatures, well, I should point out right away these tests were done with a D15 G2 and not the 360mm liquid cooler from the all-core Workloads. While the new firmware did cut down 14900K temperatures substantially, the 285K is still quite a bit easier to cool, and while the Ryzen 9000 series might consume about the same amount of power as Arrow Lake while gaming, because of their IHS and overall packaging, they actually tend to run a lot hotter. And even in a worst case scenario, neither 200K series chip broke above 60 degrees, even with an RTX 4090 blasting hot air into the D15's airflow path. To me at least, this means you can install a pretty basic air cooler onto an Arrow Lake CPU and be confident that in gaming at least, temperatures will never be a problem. This is also great news for small form factor gaming PCs, because it looks like either of these processors will play well with low profile coolers right out of the box, without needing any extra tweaking. And I guess that leads to another checkmark in Intel's favor. They said that Arrow Lake would consume less power and produce less heat than Raptor Lake while gaming, and that's exactly what happened. But the biggest question that everybody has is how much did they have to sacrifice in terms of gaming performance to actually get those power numbers. Let's kick things off with Alan Wake, since it really sets the stage for what's to come. At 720p with less GPU involvement, the Ryzen 9000 series just runs all over Intel's offerings, even the two Arrow Lake processors. Meanwhile, the X3D makes things a complete rout. Now, when comparing Arrow Lake to Raptor Lake, well, the 285K does beat the 14900K, and the 245K does match the 14700. It actually beats the 14600, which is good news. But something weird happens at 1080p, with the Intel CPUs retaining more of their performance than Zen 5. This could be due to anything from optimizations to platform preference though. Avatar, meanwhile, is a classic situation where 1080p high settings make the situation look a lot tighter than it really is, whereas the CPUs can stretch their legs at 720p. And here Arrow Lake's Ultra 9 and 5 are essentially tied with the competing i9 and i5 models, though their 1% lows are quite a bit better. Once again though, the 7800X 3D runs away with things, and the rest of the Zen 5 CPUs stay well ahead of Arrow Lake. That overall positioning, well, it doesn't change with Baldur's Gate either. As a matter of fact, the 285K and 245K get pushed even further behind the other CPUs at 720p, while the entire race tightens up again at 1080p. I mean, there's a small exception with the 245K getting better 99th percentile frame rates than the 14600, but that's the only real victory here. I'll admit, because of Arrow Lake's huge single thread results in Cinebench, I had some high expectations for these CPUs in CS2, but that didn't happen. They just fell flat on their faces against every single alternative on both the high and low in-game settings. It doesn't matter if it was against the inexpensive 9600X or 14th gen CPUs. It was a bloodbath, especially when you consider the 285K's price. Cyberpunk, well, it switches things up again by having the 285K beating the 14900K at both resolutions, while also matching the 9900X. Of course, the X3D, it's the exception here, by a long shot. The 245K, on the other hand, is competitive too, at least against Intel's previous generations, but compared to Ryzen, and even the less expensive 9600X comes out ahead. Another thing you'll probably start noticing is the ranking of these CPUs differs wildly from one game to another. Doom proves that with the 14900K pulling way ahead of everything else, while the two Arrow Lake processors put on pretty good showings relative to other Intel options, but compare them against the 9700X and 9600X and things don't look all that rosy. Another thing that's really evident here is how AMD's dual CCD models tend to struggle in some games, and it won't be the last time you see this either. I wanted to pause here and use Forza 5 to highlight something really quickly. If we'd stuck to only using 1080p high settings, the perception of Arrow Lake would be very different since, according to these numbers, it gets pretty close to the Ryzen 9000 series. But this almost flatlining of results points towards a GPU bottleneck. Remove that at 720p low, and while the Ultra 9 and Ultra 5 offer better performance than 14th gen CPUs, AMD's alternatives, well, they have a ton of juice left in their tanks for certain games. That situation gets repeated somewhat in Hogwarts, but let's take a step back and evaluate what's happening here relative to Intel's claims. They said the 285K would trade blows against the 14900K, and that's exactly what it does. But the only times it can consistently beat the 9950X is when the dual CCD design starts acting up, and that's certainly not here. Those well-documented dual CCD consistency issues come up again here with both 9900 series processors getting a serious performance haircut, allowing the 285K and even 245K to pull ahead. Both of those Arrow Lake CPUs also get better numbers than the 14th gen. And yet, those single CCD 9700X and 9600X processors end up looking really good on both sides of our settings chart, and they actually become the best CPUs for this game. And other than the titanic numbers put out by the 7800X3D, the results for Flight Simulator align perfectly with other games that don't support multi-threading. Basically, Arrow Lake's lower maximum frequency means it can't keep up with Raptor Lake or Zen 5. Looking at 1080p, well, things look a whole lot better. You just need to be aware that as the GPU bottleneck gets taken away, AMD CPUs have a lot more headroom here. AMD's dominance, it continues in Rainbow Six, especially at 720p. Meanwhile, the usual thing happens among the Intel processors. Arrow Lake sometimes win and sometimes loses against Raptor Lake without there being a clear winner. Rocket League is one of only a handful of games we tested where CPUs with 3D V-cache don't completely dominate, and the 200K series does actually do well here against the previous gen Intel offerings. And yet, Ryzen 9000 just walks away with things yet again, specifically with those 1% lows. And the situation for Arrow Lake does look a lot better in Spider-Man, where the 285K at the very least matches the 9900X at 720p, but it can also run faster than the 9950X at 1080p. Starfield is another game that favors Intel, so in general, with the exception of the X3D chip, AMD's processors typically run slower than Arrow Lake and 14th gen CPUs. But then again, the 285K doesn't really offer any better frame rates than 14900K, and the same thing can be said about the 245K versus 14600K situation. We're just not seeing that much in the way of generational uplifts here. As a matter of fact, they're non-existent. Basically, these processors are just as fast as Raptor Lake at 1080p, and they can manage to beat or tie Zen 5 at least sometimes in games like this. The only issue, at least for the 285K, is that alternatives like the 7800X3D do exist, and those will almost universally guarantee higher frame rates for less money. Also, in cases like this, 14th gen chips seem to have a bit more room to flex as GPU horsepower increases in the future. Okay, so that was a completely wild ride with all of those 15 games. But what I wanted to do is simplify things, give one source for all of the overall results of those 15 games, and I also need to explain a few things here. Let's start with why, after barely tying 14th gen CPUs in gaming at launch, Zen 5 CPUs are looking so good right now. Well, the AMD specific scheduler optimizations in 24H2 alongside other software and firmware updates have boosted gaming performance across most of the Ryzen lineup by between 5 and 15%. And that's given them a distinct edge over even the newest Intel processors. Plus, if avoiding CPU bottlenecks for future GPU upgrades is important, our 720p testing proved the Ryzen 9000 series has a ton left in its tank too. And I'm not going to mince any words here. This doesn't paint a pretty picture for Arrow Lake, at least not in terms of raw gaming frame rates. It offers the exact same gaming performance as the parts it replaces. I mean, sure, the Ultra 5 245K's 1% lows are a silver lining, but other than that, well, it is simple stagnation for gaming on Intel's only enthusiast platform. And if anything, I think the gaming results prove one thing, that if Intel is going to be charging $600 for their top level enthusiast CPU that a lot of people are going to expect is going to live in their gaming systems, they need something that will compete against AMD's X3D chips, because Arrow Lake just isn't it. And I think all of this leads me to wonder, right, is who are Arrow Lake CPUs even made for? Well, they evidently aren't for gamers, since someone can go out right now, spend $275 on a 9600X, and be reasonably sure it'll match or beat the frame rates posted by the $600 Ultra 9 285K. And while it does technically run a little bit hotter, that Ryzen chip also needs less power. Arrow Lake also isn't for people who might want to upgrade in the future, since it doesn't really seem like the LGA 1851 socket will even be around for all that long. Then again, I don't want to get bogged down by just talking about the gaming results here. Yes, those are a huge part of the conversation, but I have to give credit where it's due. Intel has made some huge strides when it comes to performance of Arrow Lake in multi-threaded applications. The 285K trades blows with the 9950X and keeps well ahead of the 9900X. Meanwhile, the 245K can, in most situations, manhandle the 9700X while costing less. So what this is I feel it's a true reset for Intel. Their architectures on the desktop side were getting too power hungry, they were producing way too much heat. They needed a reset, and that reset is Arrow Lake. And you can see that here with the two processors. The Ultra 9 285K and Ultra 5 245K can beat their predecessors in multi-core workloads and come close to matching their gaming performance, all while consuming a whole lot less power and being a lot easier to cool too. So that's where this all lies. Intel absolutely needed to take this step. And while we might not like where things landed when it comes to performance, especially those gaming frame rates, this to me is a stepping stone for future generations. And if that happens and we see constant progression while keeping within manageable power and heat loads, then it's a win-win. The only thing is that that doesn't necessarily mean that I would recommend you go out and buy an Arrow Lake processor. As a matter of fact, I actually wouldn't recommend them right now. Anyways, I'm Mike with Hardware Canucks. I hope you enjoyed this video, and I'll see you in the next one. Have a great day, guys.